In this video, we are going to be solving the 11th problem from the Leetcode Top Interview 150 list. The name of this problem is H-Index. Given an array of integers, citations, where citations of I is the number of citations a researcher received for their ith paper. Return the researcher's H-Index. So what is H-Index? So H-Index is defined as the maximum value of H such that the given researcher has published at least H papers that have each been cited at least H times. Let's take a look at an example. So here we have been given citations as 30615. So the researcher has published a total of 5 papers here, and these are the citations for each of these papers. So in this case, the output is 3, and the reason the output is 3 is that we have at least 3 papers, which is paper 1, paper 3, and paper 5, and all 3 have received at least 3 citations. That's why their H-index is 3. Okay, so let's try to look at some of the key observations here, and then we will follow up by providing a solution for this. So here it is given that H-index is defined as the maximum value of H such that the given researcher has published at least H papers. So here the thing to notice is that what can be the maximum value of H-index. So H-index can go from 1 to the number of papers researcher has published. So in this case, this will be length of citations. Okay, so H-index will always be bounded by length of citations. Okay, one more thing to notice here is that it is also being said that it is defined as the maximum value of H such that given researcher has published H papers that each have been cited H times. So in the maximum case where we have 5 papers, H-index would be 5 when we have 5 papers cited at least 5 times. Then only the H-index would be 5. So let's take an example of this. Here, paper 1 has been cited 3 times, paper 2 has been cited 0 times, paper 3 has been cited 6 times, paper 4 has been cited 1 time, and paper 5 has been cited 5 times. So one quick way to solve this is to sort the array. So if we sort the array, we get this array as sorted. So in order to find the H-index for this problem, what we need to do is we have to first sort the array and then start iterating from behind the array. And what does this mean? We have one paper which has been cited 6 times. So for H-index condition, we need X number of papers cited X number of times. So we have right now one paper cited 6 times. So this condition is not getting fulfilled. So we go back. Now our cursor is here at 5. Now we have 2 papers cited at least 5 times. So this is still not the case because we need both the number of papers and the citations to be equal. So H-index would not be 2. Then we again go back. Now we have 3 papers cited at least 3 times. So in this case, we have found the H-index. So H-index would be 3. The time complexity for this solution would be O of n log n because we are sorting the array and then iterating on the array from behind to find the H-index. So in worst case, this will be this. And we are not using any extra space, so space complexity would be O of 1. Now, can we do better? So in order to answer this question, what we need to do is we need to take a look at the input and the possible values of H-index. So in this case, the only possible values of H-index would be the from 1 to the total number of papers. And one thing to notice also is that any citation count which is greater than the number of papers does not affect the result. So it does not matter if this number was 8, 10 or anything greater than 5 because we are only considered about the equal values of citations with the number of papers. So in this case, what we can do is we can replace all the values of the citations which are greater than the total number of papers. So if we do that and then we have to sort the array, the problem basically boils down to sorting in a range. So if we replace the values which are greater than number of papers for citations array, then the problem boils down to sorting a range 1 to n. Now the best way to sort this type of array where we know that the numbers in the array are in a fixed range is to use counting sort. For this, the time complexity would be O of n, and again we can find the H-index similarly after the array is sorted, and that time complexity would also be O of n. So this way we can sort it in a better way. So the approach would be sort the citations array based on counting sort and replace the value of citations greater than number of papers, where citations is greater than total number of papers. Then iterate from the back of the sorted array and apply H-index condition to check if current H-index candidate index is a valid H-index. So this is going to be my approach. So now let's try to code this. So first, to be able to sort the array, I need to create a new array to run the counting sort. So I'm going to call this paper count, and this will be a new array which will be one size greater than the citations array. Now I'm going to apply the counting sort. So for int in citations, we want to update the paper count. So paper count of index. Now here we want to apply the logic of replacing the value of citations which are greater than number of papers. So math.min of c, comma, citations dot length, because citations dot length is the total number of papers for that researcher. And for this index, we want to increase the value by 1. Now our potential H index would be the total number of papers, and paper count for this H index would be paper count of citations dot length. Now while our H index is greater than papers, we have to first reduce the value of H index and then calculate the total number of papers. Finally, we return the H index. So in the final loop, if you see, what we are doing is every time we find that the H index at the current index is greater than the total number of papers. So in that case, what we are doing is we are reducing the H index and increasing the paper count. The moment we reach the condition where H index is not greater than papers, we know that at that H index is the right candidate for this question. And then we are going to break out of that loop and return the H index. So let's try to run this code. And if you see both the test cases are passing, so we will go ahead and try to submit this. And it passes all the test cases. So in this video, we solved the problem H index. In the next video, we are going to be solving the 12th problem from the top interview 150 list.